we're going to start talking about inverse functions today. And while I'm thinking of it, I just want to remind you all that there are no classes at GCC on Friday. So spring break starts a little bit early, so you get Friday plus the next week. Okay. Yeah, the building will be open. Yeah. Okay, so inverse functions. So pretty much everybody did fine in 1 through 3 in the preview exercises. So I figure we'll just do number 4 together before we start the demo. So we're just undoing or reversing what's been done to x here. So my first step here is that I'm going to subtract 1 from x and then multiply the result by 3. So to subtract 1 from x, I just write x minus 1. And then I want to divide that, multiply that by 3. So I have 3 times x minus 1 result. All right, so my steps were subtract 1, then multiply by 3. So when you do some stuff, to undo it, just like with the shoes example, you have to undo it in the reverse order. So what's the first thing I want to do? What's the first thing I need to undo? Yeah, I want to undo the multiplication by 3, so I'm going to divide by 3. So I'm starting where I finished before, 3 times x minus 1, and I have to divide that by 3. That undoes the multiplication by 3, right? And then I want to undo the subtracting 1. How do you undo subtracting 1? Add 1. So you have x minus 1, add 1, and you end with x. Okay, good. So this is the idea of inverses, functions that undo each other. All right, so let's let h be a function of t, and the formula is 6 plus 2t. It gives the height of corn seedlings in inches t days after they've been planted. So I'll make a table of values for f of t over the domain 0 to 3. So t is time, days after the seedlings have been planted, and then f of t calculates the height. So what would f of 0 be? 6 inches, yep. And then f of 1 would be 8, f of 2 would be 10, and f of 3 would be 12. So when you look at a table of values like that, like an XY chart or a TH chart, those are just ordered pairs. Those are points, T comma H. So I've got 0, 6, 1, 8, 2, 10, and 3, 12. So suppose I wanted to know how many days T it would take for the height of the seedling to reach H inches. Okay, how would I find T? I'd have to solve for T. Yeah, I'd have to plug in an H, plug in the H that I want, and then solve for the T. So I would solve for T. I would have H equals 6 plus 2T. Solve for T, right? When I solve for T, I just want to get T by itself, so I end up with T equals, first I'd subtract 6 from both sides, and then I'd divide both sides by 2. Okay, so in this equation, H is now my input and T is my output, so my points look like H comma T instead of T comma H. So I interchanged the roles of the variables. So let's make a new table of values where H is the input and T is the output. Okay. So my function is H minus 6 over 2. So if H is 6, if you put a 6 in for H here, what do you get for T? 0. And if I put in an 8, I get 8 minus 6 is 2, 2 over 2 is 1, 10 minus 6 is 4, 4 over 2 is 2, and 12 minus 6 is 6, and 6 over 2 is 3. So what do you notice about these two tables, the H comma T table versus the T comma H table? They're the same except, yeah, they just switched which variable was input, which variable was output. So the set of ordered pairs, if I'm defining them as h comma t, is going to be 6, 0, 8, 1, 10, 2, 12, 3. Okay, so F and G, they have same table with input and output switched. So we call these two functions, the 6 plus 2x and the x minus 6 over 2. Those were the two functions we were just working with. We call them inverse functions. Okay? They undo each other. So the fact that g is the inverse of f is expressed by renaming g as what looks like f to the negative 1. But it does not mean f to the negative 1. Okay, so that's really critical. Doesn't mean f to the negative 1. You would just read that as f inverse. Okay. So if I have two functions, f and g, 6 plus 2x and x minus 6 over 2, those two functions are inverses. So we would typically rename g f inverse. Looks like f to the negative 1 in the notation. Okay, so here's the really big idea, what an inverse function does. F and g are two functions so that when you compose them, right, you run the function machines in succession. If you always get the x that you put in to g, run it through g, run it through f, if you get x back, that is what we call what inverse functions do. That's what inverse functions do. They are function machines that when run back to back give you a round trip. Okay. This is the same as the visual process we began with in the preview exercises, right? So if you start with an x, if you apply g, your result is g of x. Then you apply f, you want to end with x again. Okay. So I like to call that a round trip. Okay, that means that f and g are inverse functions. They undo each other. Whatever g did to x, f undoes it and gives you x back. Okay. Same thing if you start with f. So you plug an x into the f machine, you turn the crank, f does some stuff to it, and then you take the result and apply function g, and g just undoes whatever f did, so you get x back. That's the definition of an inverse function. So I'm going to have you do a bunch of stuff with inverses in your activities, and you're going to be discovering a lot of stuff. So let me know if you have questions.